We're going to do some basic math vocabulary, and we're going to talk about how to use your spiral notebook to do your notes that we do, whether they're in class or online. Your spiral notebook can be a one subject or 3 or 5, it doesn't matter, but it's solely dedicated to math. And we're going to start on the very first page, and one thing that you should always do is put your name on the cover. You can put your name on the cover, what class it's for, and then somewhere else, maybe the back cover, because sometimes the front cover, because of use, gets torn off. So we want to make sure if it's lost, it was returned back to you. So definitely put your name somewhere on your spiral. So we're going to talk about how we label our page and set our pages up for notes. And anything I write on my notes should be on your notes. So it should almost be a mirror image. I'm not going to give you unnecessary things. We'll do examples. And a highlighter is good for this. If you have your highlighter, light colored's better. We're going to highlight our major words. So we're going to go ahead and make sure that we put our date. And whatever today's date is, I'm just going to use a date of our second day. So this will be 8/18/2020. And we're going to label our lesson Basic Math Vocab. Okay, so we want to make sure that our date's on there so we can easily find it, and we're going succession. So we're going to start with a word. All these words you should know, but this is just clearing those cobwebs out a little bit. So we're going to start with our first word, variable. So if you think about what a variable is a letter, and when you were little, you actually learned how to use variables in kindergarten. Your teacher might have said, if I have one little teddy bear plus 5 more, what's the teddy bear worth? If they totally equal 10. And you were doing algebra. So this is just an example. When we get to this level of math, we're using a letter that takes the place of an unknown number or value. So for example, we could use X, we could use Y, those are the most common. Maybe we'd say 2 plus a little smiley face is equal to 5, and we could figure out what that smiley face is worth. So variable is our first word. So go ahead and highlight that. Stands out in your notes, so you can easily spot the words you're looking for if you need to review back. All right, we're going to continue. Coefficient. That's a number next to a variable. So for example, maybe this is 3x. This is our coefficient, the 3. Maybe we have 2 and we have 2 variables, maybe x, y. This means multiply. 2 times the value of x times y, and 2 is our coefficient. If we have just a variable, many times people think that there's no coefficient. Well, remember, anytime it's just alone, there's an imaginary 1 there. We can think there's a 1 there, so the coefficient is 1. You can have fraction coefficients, decimal coefficients, whole number coefficients. So we always know that any number beside a variable is a coefficient. And you can go back and highlight. So I'm going to go ahead, I'm going to pause for just a second. I'm going to do the next couple of words, and then we'll talk about them. And then if you need to pause the video once you see them to write them in your notes, then you can. All right, we're going to continue. So our next one is operations. And with operations, our basic ones are adding, subtracting, multiplying, and dividing. One thing that we have to remember is that when we're multiplying at an 8th grade level, we don't use the x anymore because it can be very confusing with the variable of x. So we use either the dot up in between, not as a decimal, but in between, 3 times 4, or we can use parentheses. Any number outside of parentheses means multiplication. Same with division. We don't usually use the division sign very often in this level of math. You'll see it occasionally, but not a lot. But 10 divided by 2 is the same thing as a fraction form, 10 with a bar divided by 2. Just think that that means dividing, or part of, like you learned in 6th grade with ratios, is division. All right, so now let's talk about the difference between what you've been learning in younger grade levels versus going into pre-algebra or algebra. So we have two different things. I have a little T-chart here. So on one side we have expressions, on the other side equations. So the biggest difference between expressions is you have a group of things, but there's no equal sign. Notice that these just have numbers, 3 plus 2, no equal sign. This is a numerical expression. So it has no variables, just numbers, or we'll get to what they're called as constants. Whereas an equation will still have the numbers, but it has an equal sign and it has a value that is equal to. This is still a numerical, but a numerical equation. When we get to algebra, algebra uses variables or unknowns, things to be used, like we talked before, for something we don't know. So in this case, we have 3x plus 2, but no equal sign. So this is an algebraic expression because it has a variable in it. When we get to an equation that's algebraic, it's 3x plus 2, and it equals something. So it has an equal sign. So the main difference is algebraic has a variable or variables, multiple, could have many, and the numerical does not. Equal sign versus no equal sign, expression and equation. Our next one is terms. So terms are either a single number, a variable that's single or with a coefficient, or multiplied together. So for example, we have 4x minus 7 equals 5. This 4x is a term. This 7 is a term. This 5 is a term. So we have 3 terms inside of this problem. Now, I don't like to write on the back of my sheets. Some of you may not care. I'm going to flip to the next page. So our next question is constant. Constant is a fixed value. So in my example here, 4x plus 2 equals 10, I have 2 constants. Here's a constant, and here's a constant. They don't change. Their values don't change. There's nothing being multiplied against them. We don't know what x is worth at this moment without solving. So it could change. So 4x cannot be a constant. They are all 3 pieces terms. This is a 4x, that's a term, 2's a term, and 10's a term. But these two specifically are constants. Inverse means we do the opposite of, or reverse or undo something. So if I multiply something by 5, to undo it, I'd have to divide it by 5. If I am adding, to undo, I'd subtract. So we have to know what that word means, inverse. So it's to undo, opposite. Isolate. We think about this and people get in isolation when they get in trouble, or maybe they're sick and they have to go in isolation by themselves. We want to get the variable alone. So in algebra, it means we're trying to isolate a variable. And we may have multiple variables in an equation, but it's going to tell us what one we need to isolate. So if we're trying to find the value of x in an equation, we want to get that one alone. So we have to do some inverse operations to solve and to get those alone. Our next word is factor. Factor are numbers that can be multiplied together to get another number. So in our example, 2 times 3 is 6. 2 and 3 are factors of 6. Now, 6 has other factors. It also has 1 and 6. Multiply those together and we get back 6. If we think about numbers like maybe 12, we can have multiple factors. We could do 1 times 12 to get 12. We could have 2 times 6 to get 12, and 3 times 4 to get 12. So those are all factors. So in the case of 12, we would have 6 factors that 12 has. The word transform means to change, and that will be a big factor in algebra and also in our first unit in 8th grade. So we'll talk a little bit more. Some people use that interchangeably for things. So that just means to change something. The next term is like terms, something that's alike. So terms whose variables with any exponents are the same. So I've wrote a big expression here, and we're going to talk about which ones in this are like terms. So I'm going to use a couple different highlighters just to show you. So if you'll notice, I have 7x squared, and this is 5x. They both have an x, but their exponent is different. There's no exponent here. A lot of you would say, but actually there's a 1 there. We don't see it. It's kind of like having a coefficient of 1. It's imaginary, or it's just, we don't write it because it's unnecessary. So if we look at like terms, in this case, we're looking for anything that has an x squared in it. So if we go down the row, we can see, oh, well, there's another x squared. So we can combine those together, and we would have 7x squares plus 2x squared. So think about 7 monkeys and 2 more monkeys. And we can combine those together. So together we have 9 monkeys, or 9x squares. And then our next one, our 5x, we're looking for anything that goes with, that has just an x. So if I look, I have a 3x. So those are like terms. And then my last two pieces that are left, 9 and 2, those are constants, and I can put those together. So our next word leads into simplifying. That means we're combining like terms. So if I go back to this problem that we just had, I could combine 7x and 2x, and I end up with 9x, squared. I'm going to combine 5x and 3x, and I end up with 8x. And then 9 and 2, I get 11. So I have simplified this expression down to make it kind of clean it up a little bit. All right, let's go to our final couple. Equivalent means it has the same value. So just like a fraction of 1 divided by 2, or 1/2, that's the same thing as 0.5. Or we can have another equivalent fraction, or it might be 2/4. So things that are equivalent have the same value. 4/4 is the same as $1, is the same as 20 nickels, as 10 dimes. It's just in different views, or different ways we look at it. Balance. When both sides have the same quantity. So remember, in equations and in algebra, anytime we do something to one side, we have to do it to the other side to keep things balanced, or we won't get the right answer. But also, it just throws things off, and we wonder what has happened. You've got to be very systematic about keeping things balanced in algebra. Our next one is solution. A solution is a value that we can put in place of a variable to make the equation true. So if we do all our work and we get an answer of, say, 2, and we plug it back into that variable in our original equation, and we check it to see if it's balanced or if it's equivalent on each side, and it's not, we did something wrong. We want to make sure that solution works. It makes it true. And then our last term is evaluate. This means to calculate the value of something. So let's say, for an example, I said the value of x is 3, and I gave you this expression, x squared plus 5, and I want you to evaluate it. I want you to tell me what it's worth. So I would plug in this 3 everywhere I see x. So 3, and I like to use parentheses and put my squared plus 5. Remember, something squared does not mean 3 times 2. It means 3 times itself that many times. So 3 times 3 times 3 is 9, plus 5 equals 14. So that is an example of evaluate. Make sure your notes look good, and we'll see you soon.